Let's think about what we learned about quadratic functions in the last video, and let's see if we can apply it to a couple of different functions that we are given. So first of all, take a look at this function. F of x equals x squared minus 6x plus 3. Now this is actually, here you can see that a is 1. That's the ax squared because we're given this form here. And the b is actually negative 6. And the c is the 3. Okay, so what we want to do here is I want to try to put that in this standard form up here. And the way to do that is, first of all, if there's a coefficient of x squared, we'd have to factor that out. And when I say coefficient, I mean other than 1. So there is no coefficient here other than 1, so we don't have to worry about that. Now, what I have to do is I have to complete the square. And if you're not familiar with completing the square, you can probably Google that on YouTube and probably find a quick video on how to do that. But I'm going to assume that you know what to do to complete the square, but I'll tell you what we're going to do. This b term here, that is negative 6, in order to complete the square, we need to add a term to the x squared and the minus 6x that makes the three terms, not counting this one, but that makes the three terms a perfect square. And it turns out that all I have to do is multiply this number by 1/2 and then square it, and that will complete the square. So I'm going to take 1/2 of negative 6, that'll give me negative 3, and then I'm going to square it, and that will give me 9. So what that means is the number that I have to add to x squared minus 6x to make it a perfect square is 9. So I have to add 9 to that, and by adding 9 to that, this actually becomes a perfect square, and I can write it as x minus 3 quantity squared. Now, the trick is that if I add 9 to these two terms, to keep things balanced, I have to take 9 away from the constant 3. So I have to subtract 9 from 3, and I get minus 6. So now I have this in the standard form, and so let me just kind of show you here. So I have a, which we can just say a is 1. So I have 1 times x minus 3 quantity squared minus 6. Now once I get it into that form, I know the vertex is the opposite of this sign. The x value is the opposite of this sign, which would be 3. And then the y value would be whatever I'm adding, and I'm actually adding negative 6 here. So the y value of the vertex would be negative 6. So the vertex would be 3, negative 6. And the axis would be the vertical line x equal 3. And since a is 1, I know it opens upward, and the domain of all quadratic functions is all real numbers, and the range is negative 6 to infinity. Now, if you don't know how I got that, let me show you how I got the range. Okay, so this is actually what the graph looks like. So what I did is I found the vertex, 3, negative 6, and then I just found another point. I let x be 0 to get the y value 3, and then since I know that this point is on the graph, which is 3 units to the left of the axis here, then I know there's a point 3 units to the right of the axis right here. So really all I had to do was just draw the parabola through those 3 points. And now you can see that the range of the y values goes from negative 6 on up to infinity. So that's why the range is negative 6 to infinity. Now this other one here, I actually have to factor the negative 3 out of these 3 terms first before I can apply what I did over here. So let's factor negative 3 out. So when I factor negative 3 out of here, That's going to give me x squared minus 4x plus 1. And then I complete the square inside the parentheses here. And just like I did a while ago, I get the b right here, which is negative 4. I multiply it by 1/2, which would give me negative 2. Then I square it and get 4. So that means that if I add to x squared minus 4x, if I add 4, then that would make this a perfect square. That makes this trinomial a perfect square. And then I can write that trinomial as x minus 2 quantity squared. Well, then again, when I add 4 here, I have to take 4 away from the 1 to keep it balanced. So that's minus 3. Now notice I've got an extra set of parentheses here and here. See, I'm actually doing all this inside the parentheses with the negative 3 on the outside. Okay, so now what I've got to do next to get this in the proper form, I've got to distribute the negative 3 times this and times the other negative 3. Sorry about that. But I've also got to multiply it by the other negative 3. Well, if I multiply negative 3 times this squared binomial, I'll get negative 3 times that squared binomial. And then if I take negative 3 times negative 3, I'll just get plus 9. Now, you can't multiply this negative 3 through here because that has to be squared. So you just leave it like this. But now it's in the proper form. And so we can see the vertex take the opposite of this sign, which is 2, and the same sign as this sign, which is 9, and that will give you the vertex 2, 9. And then the axis is the vertical line x equal 2. And since the a here is negative, then we know it opens down. And the domain again is all real numbers. And then if you do a graph here, we can easily do a graph. There's the vertex. And then if you let, let's go back to the original, just let x be 0 here, and you can get that the y value is negative 3. So we know that this point 0, negative 3 is on the graph, and due to symmetry we know there's a point 2 units to the other side, which would be 4, negative 3. And then if you draw the graph through those 3 points, you'll actually get the parabola that we're trying to draw. Now this is these are very rough sketches because I'm only using 3 points. If you wanted a more accurate sketch, you could actually plot some other values. But this is all I need to get the range, because the range here, the highest value of the range is 9, and then of course the lowest value is negative infinity because it goes down forever. So the range here would be negative infinity up to and including 9. So basically here what I was showing you was how to find the vertex using the completion of the square method for these quadratic functions. In the next video I'll show you how to find the vertex using what's called the vertex formula, and it's actually a much nicer way to find the vertex. So I'll see you in the next video for that.